Univariate analysis examines a single variable, focusing on its distribution. For example, understanding the average total _ bill in our tips dataset, or the frequency of different day values. Bivariate analysis explores the relationship between two variables.
Here, we might investigate how total _ bill correlates with tip amount, or if total _ bill differs between smoker and non-smoker groups. Multivariate analysis simultaneously investigates three or more variables to uncover complex patterns. We could analyze how total _ bill, tip, size, and time all interact to influence each other, or predict the tip based on all available features. Univariate, bivariate, and multivariate analysis are different approaches to understanding data based on the number of variables considered simultaneously. Univariate analysis focuses on a single variable to understand its distribution and central tendencies. Bivariate analysis examines the relationship or correlation between two variables. Multivariate analysis explores the relationships among three or more variables, often identifying complex interactions or patterns that wouldn't be apparent by looking at variables in isolation.
In the provided Python example, we first perform **** univariate analysis. For the numerical feature total _ bill, we calculate descriptive statistics like mean, min, max, and standard deviation, and visualize its distribution using a histogram. For the categorical feature day, we count the occurrences of each day using value _ counts, and visualize these counts with a bar plot, giving us insight into the busiest days.
Next, we demonstrate ** bivariate analysis ***. We investigate the relationship between two numerical variables, total _ bill and tip, using a scatter plot and calculating their correlation. This helps us see if there's a linear relationship between the amount of the bill and the tip given. Additionally, we use a box plot to examine the relationship between a numerical variable, total _ bill, and a categorical variable, time, showing how the total bill distribution varies between lunch and dinner times.
The code produces several plots. The first two plots visualize univariate analysis. A histogram showing the distribution of "total _ bill" amounts and a bar plot displaying the frequency of dining visits per "day". The subsequent two plots illustrate bivariate analysis. A scatter plot depicts the relationship between "total _ bill" and "tip". With additional information about "smoker" status and "size" encoded. And a box plot compares the "total _ bill" distribution across different "time" categories. Lunch, dinner. The final two visualizations, a "real plot" and a "pair plot" demonstrate multivariate analysis by showing intricate relationships among three or more features, like "total _ bill", "tip", "smoker", "size", "day", and "sex" across multiple subplots and encoding schemes.